Welcome students. In this video again we are going to see some important concepts regarding polygon. Now when we talk about polygon we always talk about its interior and exterior. Now what is this interior and exterior? Suppose I draw any closed shape. So the portion which is enclosed inside the boundary we call it as interior, isn't it? And the outside portion leaving this figure and the inside portion is called as exterior. So what is exterior? So you can use shading like this particular whole portion. Now exterior portion has no boundary because we know plane has no definite shape and it can be extended endlessly. Is it okay? So exterior of the figure has no shape we say, and it has no limit, but interior has limit because it is enclosed inside the boundary. It is enclosed by the boundary. Are you getting? So any polygon or any closed shape, let us not go for polygon but we will go for general closed figure, has its interior and then exterior. Is it okay? So is it applicable to polygon also? So we say yes. If you draw any polygon, if you draw triangle, suppose if you are drawing triangle, then we say that the surface inside it is called as interior, outside it is called as exterior, and we have one more particular part which is the boundary. Is it okay? So we say that any polygon or closed figure, now I am defining only for polygon or any closed shape, divides the plane into three parts, that is interior, exterior, and of course on the curve or the shape. Is it okay? Now when we talk about interior and exterior, we come to the polygon again. Now I will draw a polygon. Suppose I am drawing a quadrilateral. Is it okay? Now this is a quadrilateral, suppose. So what is its interior? You can see. So we call these angles as interior angles because they are inside the quadrilateral. They are in the interior portion. So these angles are called as interior angles. Are you getting? So why interior is required? So we are now talking about interior angles. So interior angles are angles of the polygon which are inside the polygon. Is it clear? Now another figure I'll draw. So suppose this was the first quadrilateral which I have drawn, or I just rearrange, and another quadrilateral I am going to draw. You first identify whether this shape is a quadrilateral or not. So is it a quadrilateral, children? How many sides are there? 4. How many sides are there? Again you will find 4 sides. I am going to redraw it. So there are 4 sides again. So are these quadrilateral? So we say yes. Now what about the interior angles of these quadrilaterals? You will say that they are 90, but 90 or they are less than 180 we say. What about this angle which I am tracing? These are less than 180. But what about this particular angle? It is reflex angle. If interior angle of any polygon is reflex, at least one, if at least one angle of a polygon, which angle? Interior angle of a polygon is reflex, then such a polygon is called as concave polygon. So this kind of polygon, the second type of polygon is concave or non-convex, and this first type of polygon or quadrilateral is called as convex quadrilateral or polygon. Did you understand the definition? When we talk about a polygon, we just see the interior angles. If measure of interior angle is not reflex angle, then such a polygons are called as convex polygon. And if any one angle is reflex angle, then that type of polygon is called as non-convex or concave polygon. Understood? There is one more criteria. Now you have identified that these are the convex and concave polygons. I'll redraw. Now these are drawing quadrilateral, but it is true for all the polygons. Okay. Now I'll draw diagonals for this. What do you think? How many diagonals are there for quadrilateral? There are two diagonals. Are they lying inside? Are they in the interior of polygon? So we say yes. Coming to this particular quadrilateral, now I'll use another colored pencil and see. This is one diagonal. This is one diagonal. And how will you draw the other diagonal? So which are the non-adjacent points? So you will find these two are the non-adjacent points. So in second figure, one diagonal is inside and another is in exterior, that is outside the figure. So that is another criteria to distinguish convex and concave polygons. Are you getting? So how will you define concave polygon or convex polygon? So convex polygons are those polygons in which all the angles are less than 180. That is, they are not reflex angles. Is it okay? And this straight angle to not at all possible, but the measure of every angle in that polygon is less than 180 degree. That is one of the criteria. And what will be the other criteria? All the diagonals, they lie inside. So polygons are either convex or concave polygons. They are differentiated by two criteria. Measure of interior angles. As I told you, if interior angles are less than 180, then that will be convex. And if at least one is greater than 180, then it will become convex. And position of diagonals. So diagonals in convex polygon are always inside the polygon. And in concave polygon, one or more diagonals lie outside, in the outside part, that is in the exterior. Is it clear? We can have some figures to clear. Now what is the kind of polygon or quadrilateral it is? It is a convex. This one now which I have drawn arrow, what do you think? What kind of polygon it is? So if I join the diagonal, what do you think? Is it lying outside now? So it will be exterior. Which another criteria you can use? Check the angle. What is the measure of this angle? Of course it is. Now this is on the inside edge. See, don't look at the outer part. Look at the angle inside. Is it reflex angle? So yes, that means it is a concave polygon. Are you getting? See, let us see another one. So here, is it convex? Yes. Is it convex? Yes. Then what about this? Again, see the angle here. Can you see this angle? Only one angle, but that angle is a reflex angle. It's very difficult to identify this reflex angle in the figure. We have to look inside the figure. The interior part you have to focus. So which angle is that? That is of course reflex angle. So this polygon is concave polygon. Are you getting? The next one, what about this particular figure? So you will find there are many reflex angles here. Can you see? All these angles are reflex angle. So this is a polygon, but it is a concave polygon. Are you getting? So now I hope you have understood the difference between convex and concave polygon and how to identify. There are two criteria as you can see. So you will look for the angles, interior angles. If interior angles are less than 180, then it is convex. Otherwise it will be concave. Is it okay? But every polygon is either convex or concave. Understood? So we will categorize them as convex and concave polygon. Now, which shape I have drawn? So it is rectangle. This one is rhombus. Are you getting? So now when we talk about rectangle, we say that opposite sides are equal. And what about the angles? All the angles are 90 degree. They are equal. Similarly, in the rhombus, all the sides are equal. Is it okay? So in rectangle all angles are equal and in rhombus all sides are equal. Is it okay? Then I'll draw another figure which is square. Now in this square what happens? All sides are equal and all angles are also equal. Such a figure in which all the sides and all the angles are equal is called as regular polygon. So what we say? A square is a regular polygon or regular quadrilateral. So what is regular quadrilateral or regular polygons? Polygons having equal sides and equal angles are called as regular polygons, or in other words equiangular. See the word equiangular means what? Equal angles and equilateral. Equilateral means equal sides. Such polygons are called as regular polygons. Other polygons are termed as irregular polygon. So again a polygon can be regular or irregular. If it is regular, it cannot be irregular. If it is irregular, it cannot be regular. And for regular polygon, you need to have equal sides and equal angles. Is it clear, children? Now I have drawn a polygon here and I have taken 4 equal copies of quadrilateral. Is it okay? So what I am going to do, I am going to arrange them in a proper way. So I'll arrange first quadrilateral, then second, then third, and then fourth. What I have done, I have just brought all the angles together. First C from first quadrilateral, A from second, D from third, and B from second. And when I have arranged them, what I am observing, they are forming a complete angle. So can I say angle A plus angle B plus angle C plus angle D is equal to 360 degree? Isn't it? So then we come to the conclusion that sum of all interior angles of a quadrilateral is 360 degree. Are you getting? So in this particular video, we have seen some important concepts regarding polygon and one important concept regarding quadrilateral, that is angle sum property of quadrilateral. Are you getting, children? I hope you have understood. So thank you.